At the end of this section, you'll be able to identify and locate the components of the auto flight system, describe the layout of the auto flight system, and identify its subsystems and interface. Explain the operation of the auto flight system main components. Identify and explain the controls associated with the auto flight system. Identify and explain the indications and annunciators associated with the auto flight system. The Aircraft Automatic Flight Control System, short AFCS, is used to provide the following functions: Autopilot and/or Yaw Damper functions, Flight Director functions, Altitude Alert function. The main components of the AFCS are: 1 computer, 1 control panel, 1 advisory display unit, ADU, 3 servo actuators, 1 actuator for each axis. Refer to this table for electrical power supply for the automatic flight control system. The automatic flight control system computer communicates with the following systems: 2 air data computers, ADC, 2 attitude and heading reference systems, AHRS, 2 symbol generator units, SGU, the radio altimeter, the GNSS or GPS if installed, several switches and sensors. The Automatic Flight Control System computer generates the commands for the flight control actuators and the flight director bars. The controls and indications for the Automatic Flight Control System are provided via 1 AFCS control panel, 1 advisory display unit, 1 course and heading panel, and 1 altitude and course panel. 2 autopilot off lights, located 1 in front of each pilot. The flight director command bars and autopilot flight director modes displayed on the left-hand and right-hand electronic attitude director indicator, EADI. 2 flight director bars, switches. Two go-around push buttons located on the engine power levers. 2 autopilot quick disconnect push buttons, 1 on each control wheel. 2 normal pitch trim rocker switches, 1 on each control wheel. 2 touch control steering, TCS, push buttons, 1 on each control wheel. 1 standby pitch trim switch on the center pedestal. And the amber guidance indication light on the glare shield. It illuminates if CAT II conditions are lost or if an excessive deviation is detected. The Automatic Flight Control System control panel enables the crew to select the autopilot and yaw damper on and off and select which side, captain or first officer, is coupled to the autopilot flight director computer. Select the vertical modes and adjust the desired vertical speed or indicated airspeed. Select the lateral modes and the bank angle limit. Cancel all selected flight director modes. The advisory display unit shows advisory messages in white on the first line, caution messages in amber on the second line, armed modes in white on the third line, active modes in green on the fourth line. The reset button is used to cancel a caution message or to confirm an AFCS automatic choice. A brightness knob is provided to adjust the display. In addition, a left and right select push button is provided for autopilot ground maintenance tests. The course heading select panel is used to select the course on the captain's EHSI and select the heading bug on both EHSIs to the heading that will be used by the AFCS as a reference. The Altitude Course Select panel is used to change the selected altitude, which is displayed on the ADU, and select the course on the First Officer's EHSI. The autopilot off lights are used to provide the crew with a visual indication of autopilot disengagement. At the same time, the cavalry charge audio warning will be generated. The captain's and first officer's EADIs display the following AFCS information: the flight director command bars. Each side of the flight director command bars can be switched on and off via the left and right flight director command bar switches. The lateral armed active modes and coupled status are shown in the left top corner of the display. The vertical armed modes and active modes are shown in the right top corner of the display. The autopilot message enunciator is shown in the lower right corner of the display. It illuminates amber if a caution message is displayed on the ADU. In normal operation with the autopilot engaged and with no caution message, the green autopilot engaged message is displayed. The two go-around push buttons installed on the power levers are used to select the go-around mode. When at least one of them is pressed, the autopilot is disengaged. All armed and active flight director modes are dropped, and the go-around mode is selected. The go-around mode will keep the heading flown at the moment that the go-around mode was selected at a predetermined minimum safe pitch attitude. It can be cancelled by either using the touch control steering push button, the standby switch on the AFCS panel, by selecting a new vertical mode, or by engaging the autopilot. The following AFCS controls are installed on both control wheels. The touch control steering push button, when depressed and as long as it is kept depressed, allows the pilots to manually control the aircraft with the autopilot engaged. When the autopilot quick disconnect push button is pressed, it will disconnect the autopilot. When pressed again, it will clear the autopilot off alert indication and the respective ARL alert. If the normal pitch trim rocker switch or the standby pitch trim switch is actuated, it will disengage the autopilot. Engagement of the yaw damper and the autopilot are accomplished via the push buttons on the AFCS control panel. Both autopilot and yaw damper cannot be engaged on the ground. Pressing the yaw damper push button will engage only the yaw damper, and the white yaw damper arrows will illuminate. Pressing the autopilot push button will engage the autopilot and the yaw damper and will activate the pitch auto trim function. The white yaw damper and autopilot arrows will illuminate. Engagement of the autopilot without any vertical mode selected will cause the autopilot to fly actual pitch attitude at time of engagement. This is the basic vertical mode. The pitch wheel and touch control steering can be used to modify the pitch attitude. Engagement of the autopilot with no lateral mode selected will cause the autopilot to first level the wings and then maintain the heading reached at this time. This is the basic lateral mode, and the touch control steering can be used to modify the heading. When the autopilot is engaged with any lateral or vertical armed flight director mode selected, it will continue to fly in basic mode until the armed mode becomes active. If the autopilot is engaged with any lateral and/or vertical flight director active mode selected, the autopilot will follow the flight director bar's commands. The autopilot can be disengaged manually or automatically. Now let's take a look at the manual disengagement, which can be achieved by actuating the quick disconnect push button on the control wheel, actuating the normal or standby pitch trim, actuating the autopilot push button on the AFCS control panel, actuating the yaw damper push button on the AFCS control panel, actuating at least one of the go-around push buttons on the power levers, applying a force of over 30 decanewton, 66 pounds, on the rudder pedals, and applying a force of over 10 decanewton, 22 pounds, on the control column, pitch axis. When the autopilot is manually disengaged via the autopilot push button on the automatic flight control system control panel, the quick disconnect push button on the control wheel, the go-around push buttons, the normal or the standby pitch trim, or by an effort on the control column pitch axis, the following will happen. The autopilot will disengage without disengaging the yaw damper. The autopilot white arrows will extinguish. The autopilot off lights illuminate red, and an RO warning is generated. The autopilot disengaged message is displayed on the ADU, and the reset push button illuminates. Actuating the reset push button or the quick disconnect push button will clear the warnings and the message on the ADU. Note that if failure occurs, the pitch trim fail, pitch mistrim, or aileron mistrim message will be displayed on the ADU. In such case, the crew has to disengage the autopilot and fly the aircraft manually. Actuating the yaw damper push button at touchdown when landing or putting a force of more than 30 decanewton, 66 pounds, on the rudder pedals will disengage the yaw damper and the autopilot. The yaw damper and autopilot white arrows will extinguish. The autopilot off light illuminates and an RO warning is generated. The autopilot yaw damper disengaged message is displayed on the ADU and the reset push button illuminates. Actuating the reset push button or the quick disconnect push button will clear the warnings and the message on the ADU. During an automatic disengagement of the autopilot, the messages and warnings are the same as during a manual disengagement, except that the autopilot off light and the autopilot or autopilot yaw damper disengaged message will flash. Actuating the reset push button or the quick disconnect push button will clear the warnings and message. The autopilot may be manually overridden on roll axis if sufficient forces are applied to the control wheels. This action does not disengage the autopilot. Note that if the pitch trim asymmetry amber light illuminates on the instruments panel, the autopilot automatically disengages and cannot be re-engaged. In case a monitored failure is detected, the autopilot and/or yaw damper will be disengaged and the respective failure message is displayed on the ADU. By pressing the reset push button on the ADU within 45 seconds, The failure message disappears, and the autopilot computer tries to reset itself. Once the autopilot computer power-up test is completed, the autopilot and yaw damper can be once again engaged. If the initial failure persists, the autopilot and/or yaw damper will disengage again. The automatic reset is done only once, and if a new reset becomes necessary, it can only be accomplished by cycling the associated circuit breaker. The automatic reset is inhibited if the autopilot, yaw damper, or AFCS control panel is lost. The pitch trim fail alert is lost. The approach, go-around, localizer, or back course modes are engaged. The flight director, FD, provides guidance information to the pilots via the vertical command bar and the horizontal command bar on the EADI. The flight director commands are considered satisfied when both vertical command bar and horizontal command bar are centered on the EADI. The vertical command bar will only be visible to the pilots if a lateral active mode is engaged, while the horizontal command bar will only be visible if a vertical active mode is engaged. Both vertical and horizontal command bars can be removed by selecting the respective flight director bars switch to off. The flight director can be used without the autopilot. Lateral and vertical mode status indication is provided on the EADI and the ADU. When the autopilot is engaged, it will normally and automatically follow the flight director commands. Note, if the autopilot is engaged without any active mode, it will fly in the basic autopilot mode. The following modes are available on the Automatic Flight Control System control panel. Vertical modes. Altitude select. It is armed automatically when the aircraft is climbing or descending towards the selected altitude. Altitude hold. To maintain the actual altitude. Vertical speed hold. To maintain a required vertical speed in climb or descent. Indicated airspeed hold. To maintain a required indicated airspeed in climb or descent. Lateral modes. Heading. To maintain a heading. Navigation. Can be used for maintaining a VOR radial. VOR is displayed on the ADU. The localizer during the approach, LOC, is displayed on the ADU, or the RNAV information provided by the GNSS or GPS, LNAV, is displayed on the ADU. Back course. To fly a back course ILS approach. Common modes. Approach. To fly an ILS Category 1 or Category 2 approach. Go-around. Used during the initial part of the go-around procedure. The vertical and lateral modes are engaged by pushing the corresponding push button on the Automatic Flight Control System control panel, except for the altitude select, which is automatically armed, and go-around, which is engaged via the go-around push buttons on the power levers. Some modes are engaged with an initial armed status. An armed mode means that the mode is engaged but needs to meet certain conditions before becoming active. The engagement of armed modes is limited to one lateral mode and two vertical modes simultaneously. In this case, the vertical mode, which after meeting the capture conditions will become the active mode. Before becoming active, the mode goes into the capture phase. while in the capture phase, the mode is displayed on the ADU and EADI in green and is followed by a green star symbol. After the capture phase, the mode becomes active. The star symbol disappears, and the mode is still displayed in green on the ADU and on the EADI. A mode disengagement is performed by pushing the applicable push button on the AFCS control panel, which will disengage that mode. Pushing the standby push button on the AFCS control panel, which disengages all armed and active modes. Pushing the go-around push button on the power levers, which will disengage all armed and active modes and engage the go-around mode. Note that when an armed vertical or lateral mode becomes active, the previously active vertical or lateral mode is automatically disengaged. The Automatic Flight Control System computer uses data from the Captain's and First Officer's Air Data Computer and Attitude and Heading Reference System. The system uses an average value for basic stabilization computations. For guidance computations, the Automatic Flight Control System computer is coupled either to the Captain's or First Officer's side via the coupled push button on the AFCS control panel. It then uses data from the coupled air data computer and symbol generator unit and displays the same commands on both sides. At aircraft power-up, the left side is coupled by default, and the corresponding arrow on each side of the coupled button indicates the coupled side. Take a look at the table Automatic Flight Control System Limitations. When the coupled push button is pressed, all vertical and lateral modes that do not use symbol generator data, altitude hold, altitude select, vertical speed, indicated airspeed, and go-around, will be retained, and the flight director will provide commands for a smooth transition maneuver if the data on the new coupling side is different. For example, a different barometric setting. All modes using symbol generator data, nav, back course, and approach, will be disengaged if the coupled side is changed. During an ILS approach, only a dual coupling will automatically occur after both localizer and glide slope modes become active. Localizer and glide slope green displayed on the ADU and EADI. If both nav receivers are tuned to the same ILS frequency, both coupled arrows will illuminate. And both nav receivers are coupled to the AFCS computer, which will use the average data for guidance computations. In case the approach mode is manually canceled, the flight director remains coupled to the previously selected side. When flying an ILS Category 2, the excess deviation monitoring device fitted in the AFCS computer uses ILS data from both SGU. In response to a component failure, the autopilot will take the following actions. If one sensor used for guidance computation fails, the autopilot can still be coupled to the respective side, but the flight director modes using the invalid sensor cannot be engaged. In case of an ILS failure, when not in dual coupled phase, the autopilot remains engaged on the coupled side. And in case of an ILS failure in the dual coupled phase, the autopilot will perform an automatic selection. In case of a failure within the AFCS, an autopilot message will be displayed on the EADI and an explanation message will be displayed on the ADU. In this section, you'll learn about the AFCS vertical modes and their usage. The AFCS vertical modes are the altitude select mode, the altitude hold mode, the vertical speed hold mode, and the indicated airspeed hold mode. When an altitude is selected, and the aircraft is climbing or is descending towards the selected altitude, the Altitude Select mode is automatically armed. This mode has three phases: the arm phase, the capture phase, and the hold phase. Arm phase. The Altitude Select arm mode is enunciated on the advisory display and the EADI by a white alt message. Any vertical mode, for example, vertical speed hold, indicated airspeed hold, or pitch hold, can be used to fly to the selected altitude. Capture phase. When the pre-selected altitude is approached, the system automatically cancels the previous vertical mode and switches to the Altitude Select Capture mode, which is indicated by a green Alt asterisk on both ADU and EADI. Observe that if during the capture phase a new altitude is selected, the autopilot will return to the basic pitch hold mode. Hold phase. When the pre-selected altitude is reached, the Altitude Select Capture mode is automatically cancelled. The Altitude Hold mode becomes active, and the green Altitude asterisk message is replaced by a green Altitude message on both ADU and EADI. If the altimeter setting is changed on the coupled side once the Altitude Hold mode is active, the autopilot will automatically correct the aircraft altitude to the altitude set on the ADU, based on the new altimeter setting. Note that a glide slope capture during any of the three phases will override the altitude mode. When the altitude push button on the AFCS control panel is pushed, the altitude hold mode is activated and overrides all active flight director vertical modes. The aircraft will maintain the altitude existing at the engagement of the mode, and a green ALT will be displayed on the advisory display and the EADI. By pushing and holding the TCS button on the control wheel, the aircraft can be maneuvered to a new altitude reference without disengaging the mode, and the aircraft will maintain the new reference as soon as the TCS button is released. Note that when a glide slope capture occurs, it will override the altitude hold mode. When the vertical speed push button on the AFCS control panel is pushed, the vertical speed hold mode will be engaged and override all other active vertical modes. The vertical speed existing at the time of engagement will be maintained and displayed on the advisory display. The pitch wheel on the AFCS control panel can be used to set a new vertical speed reference without disengaging the mode. By pushing and holding the TCS button on the control wheel, the aircraft can also be maneuvered by the pilot to a new vertical speed reference without disengaging the mode, and the aircraft will maintain the new reference as soon as the TCS button is released. Caution: when using the vertical speed hold mode during climb, the pilots must monitor the aircraft airspeed, since the autopilot will maintain the selected vertical speed regardless of the actual aircraft airspeed, which may lead to a stall situation. When the indicated airspeed push button on the AFCS control panel is pushed, the indicated airspeed hold mode will be engaged and override all other active vertical modes. The indicated airspeed existing at the time of engagement will be maintained and displayed on the advisory display. The pitch wheel on the AFCS control panel can be used to set a new indicated airspeed reference without disengaging the mode. By pushing and holding the TCS button on the control wheel, the aircraft can also be maneuvered by the pilot to a new indicated airspeed reference without disengaging the mode, and the aircraft will maintain the new reference as soon as the TCS button is released. Note that it is recommended to use the indicated airspeed hold mode instead of the vertical speed hold mode in climb. If it becomes necessary to use the vertical speed hold mode due to a vertical speed constraint, the actual aircraft airspeed must be monitored carefully. In this section, you will learn about the AFCS lateral modes and their usage. The AFCS lateral modes are the heading select mode, the navigation modes, the back course mode. When the heading push button on the AFCS control panel is pushed, the heading select mode will be activated and override all other active lateral modes. The heading select mode is enunciated on the advisory display and the EADI by a green heading message. Heading selection is performed via the heading knob, and the selected heading is displayed on both EHSIs via a blue heading bug. Note, selections of more than 180 degrees will cause the system to order a turn as short as possible if the selection was made before heading mode was engaged. If the selection was made after the heading mode engagement, turning command will occur in accordance with the side selected. The bank push button on the AFCS control panel allows for the selection between the high bank angle limit, 27 degrees, and the low bank angle limit, 15 degrees. Alternate actions on the bank push button causes alternate selection between high bank and low bank limits. Once the system is powered up, the initial indication is high bank angle limit, and if the low bank angle limit is necessary, after pressing the bank push button, it is indicated by a green heading select low message on the advisory display. Keep in mind that due to performance limitations, all takeoffs must be performed with the low bank angle limit. Note, if the heading select mode is active, any armed lateral mode once captured will override the heading select mode. The nav push button on the AFCS control panel is used to arm the lateral guidance for capture of the selected navigation source displayed on the active EHSI. The illuminated coupling arrows on the AFCS panel and the EADI arrow point to the active EHSI. Depending on the selected nav source and frequency tuning, this can be VOR arm, localizer arm, or LNAV if installed. The VOR Navigation Mode is armed if a valid VOR frequency is selected on the nav control box. The EFIS control panel, which will be explained in detail during the chapters Flight Instruments and Navigation, has the VOR localizer mode selected, and the nav push button on the AFCS control panel is depressed. Arming of the mode is indicated by a white VOR message on the advisory display and the EADI. The heading select mode is normally used to fly the aircraft until the VOR capture phase. During the VOR capture phase, the previous lateral mode is cancelled and the indication on the advisory display and the EADI changes to a green VOR star. On the EADI, a white box surrounds the message for the first 5 seconds. When the system changes to the VOR track mode, the star symbol is removed. The accuracy of the VOR track mode increases significantly if there is a DME associated with the respective VOR. Conversely, the accuracy is reduced if the VOR frequency is used in hold mode. We'll explain the VOR hold mode during the navigation system chapter. Once flying over the VOR station, the system reverts to the capture phase. And a green VOR star is again displayed on both ADU and EADI. If required, a new VOR course should be selected only during this period, and the system will then track this new course. The localizer navigation mode is armed if a valid localizer frequency is selected on the nav control box. The EFIS control panel has the VOR localizer mode selected, and the nav push button on the AFCS control panel is pushed. Arming of the mode is indicated by a white LOC message on the advisory display and the EADI. The heading select mode shall be used to fly the aircraft until the localizer capture phase. During the localizer capture phase, the previous lateral mode is cancelled, and the indication on the advisory display and the EADI changes to a green LOC star, and on the EADI the message is surrounded by a white box for the first 5 seconds. When the system changes to the localizer track mode, the star symbol is removed. Note, there is no overstation and no after overstation capability of the system during this mode. The back course mode is set up and flown like a front course localizer approach, but in this case the back course push button is selected on the AFCS control panel. Note that in this case the glide slope capture is automatically inhibited. The instrument landing system approach mode allows the pilot to fly a fully coupled ILS approach. Observe that a valid ILS frequency must be selected on the respective nav control box, and that the EFIS control panel must have the VOR localizer mode selected. The appropriate localizer inbound course has to be selected on the EHSI. And the heading select mode shall be used until intercepted by the localizer. Pressing the APP push button on the AFCS control panel will arm the approach mode. And a white LOC and GS annunciation will appear on the advisory display and on the EADI. When the airplane approaches the selected course and enters the capture phase, the green HDG indication is cancelled, and a green LOC star message will illuminate on the advisory display and the EADI. As soon as the aircraft enters the localizer track phase, the star symbol disappears. At glide slope capture, the previous vertical mode is cancelled, and a green GS star on the advisory display and on the EADI will illuminate. When the aircraft enters the glide slope track phase, the star symbol disappears. Note that glide slope capture is interlocked in a way that the localizer must be captured prior to glide slope capture. During an ILS approach, and if all aircraft CAT II conditions are met, the crew is advised by a CAT II message displayed on the first line of the advisory display. If the conditions are not met, a CAT I message is displayed. In case Category 2 conditions were initially met and then lost, a CAT II invalid flashing amber message is displayed on the second line of the ADU. In addition, a 3-click RL warning is generated. Each engine power lever is fitted with a go-around push button. Pushing one of them will drop all armed and active flight director modes and select the go-around mode. The autopilot will disengage, and the flight director provides commands to the pilot to maintain a predetermined minimum safe pitch attitude and to maintain the heading at go-around engagement. The go-around mode is enunciated on the ADU by a green heading hold and GA, and on the EHSI by a green hold and GA. The go-around mode is normally cancelled by selecting heading, low bank, and IAS on the AFCS control panel. After cancelling the go-around mode, the autopilot can again be engaged. The automatic flight control system altitude alert function is used to alert the crew when reaching or leaving the pre-selected altitude via an amber light located on the altimeters and an RL signal. The altitude alert function will become active when the actual altitude is plus or minus 250 feet and plus or minus 1,000 feet of the selected altitude. The signal will be activated each time the aircraft enters one of the two altitude zones.